I'll talk to you later.
All right, welcome back. One quick piece of information is that our colleagues from Merced that are working on the data science project are having a side meeting in that side room. So we're going to try and stay in this room and not bug them till the coffee break. So we're now back together in plenary. Sean has like a part 2 of the thing that he did in the past hour. But I'm going to try and just give an overview of the technical side of things. And then Sean has like a little demo that we can work through. So we're always changing this every year when we do it. And I have many more slides that I can get to in this than this short amount of time. But I'm going to speed run just an overview for folks that are new to the teaching. And I'm going to skip over the part that we did last year that was like how to open Data 8 in 4 other platforms. So that's in the slide deck that I'm not going to get to, but if you want to talk about that, we're still quite bullish on Jupyter Lite. Last year we did a bunch of work to make Jupyter Lite work. We definitely see that as the future in this space. So I'm interested to talk about that as well. All right. I'm just going to talk about a few things. One is like what we're sharing, and think about this as our sharing. Another one is about just what are the different ways that we can think about Jupyter as a project. So in a lot of ways, this workshop and us teaching is about using Jupyter as a teaching tool generally. Yes, we're talking about Data 8, but we're also sort of like, what is it like to teach in Jupyter? I teach an economics class, as I've already been outed as. I have 50 notebooks in lower division economics and 50 notebooks in upper division economics. And me as a teacher, I sit and fiddle around. And I'm like, what's a cool thing from the news that I could share with my students in the Jupyter notebook? So I'm like more on the page of like all disciplines can do this generally. So a lot of the stuff that I want to share with you today is from my talk that's like, faculty that aren't data science faculty, but how to think and teach with Jupyter. And how can we sort of like evolve education and get students engaged. And so we will be doing a little bit about the infrastructure behind things. So one thing we think about is we are learning, we're other types of educators, and we have infrastructure as code. So we see the elements of these open source software packages that are delivering things to our students. In the Canvas world, we don't think about that. We don't think of like, how does Canvas run? Where is everything? We just like set up our course and run the course. But a little bit about what working in this data science world is getting you to think about the code that's behind it, sort of internalize some of those practices behind it. Another whole thing, and this is like I learned from coming here, and John De Niro and Anya Adhikari had built this course, and just learning how curriculum was also being treated as code as well. So they took these best practices from software engineering, best practices from open source software, and applied that to the education space. But why is that interesting is because I know that you can all come here and get instantly free copies of everything that's ever been taught in Data 8 ever. Like back to 2015, every lab that's ever been taught is in a public repo and you can access it. All the tools are in public repos where things have been built, right? So this is a really interesting thing about like, and it's sort of changing education overall in terms of like, it needs to be printed by a publisher and hit behind a paywall. Like we're changing that and it's making democratic access to things in a powerful way. So just trying to pitch that as well. All right, so what's this Jupyter thing to think about? One thing is it's a file. One of the founders of Jupyter Notebooks, unable to be here, Fernando Perez. This was originally made for scientific reproducibility. I am in a physics lab analyzing the data from the satellite about the black hole at one university, and I need that code to be able to run perfectly at another university. This was really hard to do, and like software packages and dependencies and things. So they made this file that could be sent all around the world and show what the code was and show what my steps were so I can run it at different research centers. It just so happens that's super powerful for teaching. I'm the teacher, I got this code set, but I want every kid in the class to have exactly the same compute and exactly the same environment. It runs perfectly exactly the same way. So it's sort of built about scientific reproducibility, but built well. I'm not sharing.
Also, it doesn't look like these slides are.
Yeah, I think the slides posted are from the previous session.
Yes.
Okay. Can you send this, the name of the slide deck, to Brandy? Where am I not sharing? Sorry about that. Instructional technology.
Should have just put it all in.
So there is a thing. That is the cool thing. It's just, honestly, the cool kids put their slide decks in the notebooks. That requires a little bit more savvy than I have. But yes, if you want to go, then we're going to talk about Otter later. And the founder of Otter did this presentation last year at JupyterCon, where he did the Otter presentation in the Jupyter Notebook slides. So if you want to see a great example of that, it's in the demonstration there. All right. So anyways, we're getting students to learn in Jupyter Notebooks. That's sort of the objective. Like and it has a bunch of things to it, right? So the students have a little bit of compute that they're exposed to in a way that they didn't have to deal with. There's a pedagogy in the file, like in the homework itself, it's teaching them what to do and what the steps are. And then they have a copy that they can keep. There's a lot of students that will like go on to the next class, but they'll have this archive of all the notebooks that they did and all the code that they did. And they can go back and like, oh, later when I go to do something else, I can remember how I did this in a previous class. So they're like building a portfolio of code over time as well. Okay, so we need a place where these notebooks open, right? And if you're not at this conference and you're just a normal person, you go and install a free software package. That's Jupyter Lab. So you go to Jupyter Lab, you go to Anaconda, you can go and download this application that's going to run Jupyter on your computer. It's going to show up in your browser window, but behind that, there's something that's basically going to run the compute, right? You can also do that in Colab, VS Code. There's all these ways you could open lab things other ways, but think of it as like, there's a free software that runs all this in the background. We think as educators, it's kind of a pain in the neck to get 100 students on 100 different laptops to install things. That's why we're like all using this hub. But you know, behind the scenes, and I would say as a teacher, when I'm writing my lecture notebooks, I'm all doing that all locally. Like I have a way that I just open the notebooks on my laptop and work with them, and then I post them when I'm done. But we can think about that space. There's this thing, this server that we have created, right? And this is how data runs. Almost everybody's logged into this server today. And this is Jupyter Hub. It's working on Google Cloud. We don't even know where those files or anything are. They're in like a warehouse in Eastern Oregon, right? And we are, for very low cost, because of the way things can be shared and load balanced, able to make a tiny bit of compute available to everybody and a tiny bit of disk space available to all of the students. And Sean here, for if you're from a California community college, many people know, makes them available to community colleges in California. So what this does is the first day of class, you're just clicking a link, it's popping open, you didn't install any software. You know, that it's very easy for the students to start learning and feel like they're winning. You know, like at the end of day 8, you'd be like, all right, now go install Anaconda, and you can run everything that you just did on the Anaconda command. There's documentation built as open source software. There's a famous story, the littlest Jupyter Hub. You can go online, sign up for $100 free credit, run your own Jupyter Hub. And this was made for an earlier version of this conference. The guy who like maintains Jupyter Hub made up a demo for like just to show people how to do things. And this package is like people around the world use it. So it's just a cool way that there's actually feedback between like this conference and like the deployment of this project globally. All right, so we're all trying to share things. If you're new, I made a 2-pager. There's like a 2-pager. There's like all of these things that we're trying to share. We also just have a web page you can go to that's like how to use data 8, how to use data 100. These are just like aggregation sites for the things that I'm going to mention. Another thing, and my colleague Balaji's not here. Did you meet with Balaji yesterday? Yeah, so I have a colleague Balaji that I work with, and he's taken over a project that's providing documentation for the instructors. And this is a book that's written for UC Berkeley instructors, but millions and millions of the tips on here are going to work for anybody teaching this way. So the stuff that we're doing that's like how to use MD-Gitpillow links, how to troubleshoot things, how to go back and fix things, how to upload things to GitHub, like all these steps. Because sort of my job, more in the past than now, but has been, reach out across UC Berkeley, find the biology professor or the physics professor, many different levels of familiarity with coding, and sort of get them familiar with this Jupyter-based instruction. And so this has like a collection of like us troubleshooting and explaining things to people over time. Another way that's interesting to think about all this is that this documentation is made up of markdown files in Jupyter notebooks, right? So this is just the same as the textbooks that we're making for the classes, but it's like making a documentation set. And then Sean moving, this is an interesting recreation. This was an older Jupyter book that had been around for a long time that was called 0 to Data 8. That's hosted on the Data 8 org site. So this is another book that you stitch out of Jupyter notebooks. And Sean has been recently updating this with the stuff that he's doing to show people how to do stuff and putting little videos in there. So there's like little video walkthroughs of different steps of things. So this is sort of like a live project where things are being added to like every couple months in the 0 to Data 8 world. If just to go into Data 8 specifically, if you want to join in and sign up, again, if you're in California, you can get a Jupyter Hub for your institution. There's a private repo that you can get that's all the homeworks, labs, and projects, all the discussion materials. So earlier today, if you were in that part, there was like the handouts or the calendar. There's lecture videos that somebody asked about using it for a flipped classroom. And then there's all these notebooks are using Otter-Grading. So that's what we're going to talk about in the second half is the Otter-Grading. If you're new to this, be kind to yourself around the Otter-Grading. It's hard and it's fiddly and it has a little ramp to it. So get yourself like comfortable with teaching and learning in Jupyter notebooks is the first thing to do. Don't try to do the Otter-Grading like right away. All right, so just this is the work that we've been doing. These are a bunch of different community colleges. HBCU, there's a CSU one. A bunch of different people using these Jupyter Hubs. This is this interesting thing about open infrastructure and open curriculum where we're able to like onboard people and share this workflow and get more people involved. And we're still onboarding and still building this over time. What's the Data 8? So I don't know if this was covered by Jonathan or John, but like 10 labs, 12 homeworks, 3 project notebooks. So you think of this is a suite of Jupyter notebooks that's coming as a bundle, and they're quite pedagogical, and they're quite linked to the textbook, right? So the students are in the lab, and they're working on something that there's something very similar in the textbook that they can check on. There's very like careful and thought out progression of how you go through the topics, where your assignments line up with your readings and the worksheets. There's a lot of past exams and finals, so that's also really helpful. The big one that we share is called Material Spring 22, and that's sort of the Spring 22 version of Data 8 that there's various public ways to look at. So these are all on GitHub, and you can go to GitHub and click that green button and download the whole thing as a zip folder. You can just get it all onto your computer as a zip folder if you want to explore it that way. But some of what we're doing here is teaching you to use GitHub as an educator in this, you don't have to do everything on GitHub, but it's a little way that you can finesse things and distribute things cleanly to your students. And if you were in the first section, look, in the same Lab 2 folder, there's the CSV files and the PNG files. That's what we were teaching. That's what Sean was teaching about in the other room earlier today. All right, so one of the best things in the starting place that I send a lot of people is this one that's Data 8 Demo External Calendar that has the calendar at Berkeley. This is what the course looks like at Berkeley. Like this is week by week, slides, demos, videos. These are going to be locked to Berkeley only, and then where the chapters. So like this is just like the framework of the course. Sean made a mimic copy of that's external facing. But it has different columns. It says open in HTML. So open the notebook, without any compute, but it opens really fast and you didn't have to authenticate. So sometimes when you go and want to go check what's in lab 2 or is that in lab 3, if you hit that HTML column, it'll just load instantly, like as a web page. And then there's like how to open a demo hub, how to open a collab, how to open in code spaces, and this is sort of the frontier. If you go to the page of like those rightmost columns are like, can we get it to open free on all the different platforms that it possibly could? But there's a lot of people around the world who are using these materials in Colab, so that's definitely a thing. And Colab has gotten better at, the Otter-Grading and Colab are now compatible and they work in a way that they weren't able to a couple of years ago. Or pledgy. All right, so I just want to wrap up with like this overview of the teaching workflow. This is something we want to think about. We're a teacher, either we got a set of notebooks or we're writing our notebooks. So we have some notebooks and we're going to use GitHub and NV Git puller links to distribute them. Students are going to use them and students are going to submit the work. So this is, if you're new to this and you just want to teach data 8, you could just get a copy of everything. You can go to the repo, you can fork it, you can just clone it onto your own thing. You can make a new org for your organization, or you can go and make new ones. So a lot of times what I do for my class is like the labs continue semester to semester, but the lecture notebooks, I'm writing up new ones each year, right? So the part that the students are doing with the auto-grading, like that's sort of like repeating over time, but I'm making fresh material in the demos that I do. But anyways, I have some way that I make notebooks and I sort of like embed some teaching in it, or if I'm lecturing live, then it'll be like a bare bones notebook where I'm going to fill it out in a demonstration way. I got a public GitHub repo for my class. I can think about how it's organized. So this has, lab 01. So there's some structure that you want to follow for your course. And you are, basically like for my class, it'll be like lecture, lab, homeworks. And so I'll just be going to the lecture folder and like which week I am in the lecture folder. So you have to have some pattern that you follow. And then I'm uploading before class to GitHub. And the other thing to think about though, if you go to the data 8 or even in my class, you go to the data 8 repo, the data science Python package is served from there and built from there. The textbook is built from there. The website is built from there. And all the materials the students do are deployed from there. But if you want to dig around and find stuff, there's actually like a ton of stuff that you can find there. So like all these different things are pulled from different parts of the Data 8 GitHub repo, including the textbook and the website itself are served as GitHub pages. Then we're going to make these magic links that was demoed a little bit before. We can demo this again. We mostly use a Chrome extension. So there's a Chrome extension. You specify the URL of the server that you're using and say that you want to open up the materials. And this is an interesting thing pedagogically too. You could make one NV Git puller link for the whole semester. And the students could go and navigate and find the file for this week, especially if it was labeled nicely, like week 1, week 2, week 1 notebook, right? You could just be like, hit that same, NV Git puller link every week, and they would pull whatever is fresh in, and the students can go to it. Differently, the way that Data 8 is thought about is there's a unique link for every notebook. So every time you build a notebook, you build a unique link. So there's maybe like 35 in a calendar. There would be like 20 or 30 unique links that will just open you in the homework or lab that you need to be in. So you can decide that it's basically like and calibrate it to the levels of your students, whether you want them to navigate to something or just have it show up for them. So you distribute these links. It's a very long, complex link that says, hey, open up this data hub, open it up under whatever the person's name is. So this user redirect part says, if I'm logged in as Eric VD, it will log it in as Eric VD's. And then do this git pull. That's why we need to use GitHub, because we haven't figured out how to make Google Drive work yet. Someday we will. So git pull from a public repo. Okay, here's this public repo. And I'm going to open it in lab. and I'm gonna go all the way out and open this specific notebook. Right, so some syntax here, you don't need to think about this, mostly let the Chrome extension handle it. And the students don't have to see this super ugly thing. They're just gonna see a link that says homework 1. So this is sort of the special sauce, how you're distributing things. Students go in the notebook, they walk through it, or like they go to lab and the TA helps them walk through it. Anytime they see 3 dots at the ellipses, when you see ellipses, it's something you need to fill in. So you fill that in, and then there'll be a part where like the auto grader is going to check how you've done. And the students, you're a teacher, you're like, I need to receive these, I need you to turn these in. There's multiple ways you do that. You could use GitHub Classroom, and the students could like submit them in GitHub Classroom. You could use them in Canvas. You could collect either the IPYNV, the notebook files, or PDF files in Canvas. What Berkeley does is they have something called Gradescope, and Gradescope allows you to auto grade in Gradescope itself and can return the scores and keep track of the scores for the students. So, and importantly, in the data 8, there's some part that's coding, and there's some part where you wrote in an answer, right? So Gradescope can handle distributed workflows where the thing that needs to be what we call manually graded, like grade a written question, can be sent to some grading TAs, and the part that's going to be automatically graded by just running a Docker container and executing the notebook can be handled directly by Gradescope. Not everybody has Gradescope, so we have different workflows for other people who don't have Gradescope, especially community colleges, to submit that and get that run for them. Mark?
So one of the selling points of Gradescope, right, is that it can automatically grade, among other things, computing assignments.
Yep.
And it'll play with Otter, like Otter is one of the options for.
That is correct.
Thank you. I know you said that, I just couldn't believe it.
Yeah, and it's part of, well, you know, I would say it's more the other way, where like Otter has been designed with the Gradescope workflow in mind, and part of writing the auto assign steps makes you the configuration file that you need to when you make a new assignment in Gradescope, you have to give it like this configuration file, and so AutoGrader makes that for you. So
it also works with GitHub Classroom. You said
Otter does not execute on GitHub Classroom. That would be like another step. I just meant like you could have your students, if you were like in a class where you were using GitHub Classroom to distribute things, you could have your students upload, you know, by midnight, commit to GitHub Classroom.
I'd be interested though in looking at GitHub Classroom. I hadn't thought about it until you just said it.
It's possible. We should figure that out.
Yeah.
There's got to be an action.
You can spin it up and stuff. So
yeah. There's probably an action. We just haven't like figured out that workflow. Okay. Sean has built a standalone Otter service grader, so that was like to handle this for people who didn't have Gradescope, where you can just go and upload things directly. And then, but it's also built as like, if you're familiar at the command line, you can just get a folder full of your students' homeworks, write one line on the command line, and then it will grade all those notebooks on your command line. So that's also like the free way to do things. All right, I'm going to stop there. In this slide deck, there is like Jupyter Lite, Colab, CodeSpace. So we're also interested in like, suppose you're somewhere else that doesn't have a Jupyter Hub. There's multiple other ways to run things as well.
You're going to get this on.
I'll fix the link on the website, I promise.
Yeah.
Think it's good? I think Denai got it. Okay, I'm going to turn it over to Sean, who has a little demo. So we're going to run this as demo if you can.
Yeah, demo if you can.
If you can't demo, just follow along. But if you're excited to log in, hopefully you could try and.
So what we were gonna try and show is what we're gonna show.
We're gonna do it.
We're gonna do it is
go and do it up here.
Yeah. It's how we get how we integrate Otter into the notebooks. So if you were there earlier before lunch. Sorry,
I'm good.
Okay.
Figure out what I should get rid of. I'll just put this on the table.
Eric gave me the trick of the 3-finger to go back and forth.
This is like, how do you teach
Super
between
happy about that.
slides
Yeah.
and the Jupyter?
Okay, so if you go to the agenda and you go to this time slot, you'll see a part 2 that you can open up, and should be these slides. Right, slides, yes. I'll let people do that for a second. But there's a bunch of links in here that if you're wanting to follow along, there's really 2 links. But once you got that, then you would get the demo part 2 notebook.
There are 59 people in the slide deck, so everyone's there.
Okay, everyone's there. Okay. And so if you click here and you get on the workshop hub, if you are not logged in, you can put whatever username you want. And then if you put in that password, or Jamal was able to just get in. I don't know what password. Who knows? Yeah. Maybe it's just open. So when you open it, you would be in this view.
If I still go to the main section agenda and open that, it's still getting me taking me to the wrong place.
Maybe you have to refresh the slides.
I hit the refresh.
I mean, refresh the agenda, sorry.
Yeah, that's what I did.
It's the same one. It doesn't start out the same one. If you scroll down a couple pages, you'll get to this one.
It's in the authoring and otter. Okay.
Yeah, you just got to scroll down.
Slide. Okay, so 3rd or 4th slide.
Yeah, it's the right link for me.
Thank you. Thank you very much.
People there.
Yeah, I'm there. Sorry.
All right.
Okay, so
This was part 1.
this was part 1, but part 2, we're using the same stuff. So in part 2, what we're trying to do, and those of you that weren't there for part 1, I'll kind of explain what we did. In part 1, we said you have a lecture notebook. How do you edit that notebook? And went through a series of steps around that. In part 2, now we are wanting to show what is Otter, and how to make an Otterized notebook, we call it, or a notebook that's going to do self-grading both on the student side and be able to be automatically graded on a server, whether it's Gradescope or our own services. So that process is a little bit more complex. So this is why those of you guys were in the first one when I kept saying, when you're going to make edits like we were making, you make sure you make those inside of a normal lecture notebook, that kind of notebook. If you want self-grading, that takes a little bit more effort to pull off. Oh, I'm not sharing my screen. Zoom hell. Okay, here we go. Okay, here we go.
You
Cool.
got it.
Boom. We're good. No, we're good. Okay. All right. Cool.
It's slideshow.
Okay, so the demo will be this. We're going to get into a notebook, and what I have termed, and I don't know if anybody else terms this, we call it a raw notebook. And there's a specific reason why I call it that, and it's kind of a weird name. But we're going to get in a raw notebook, which is going to have your normal Jupyter notebook markdown code cells plus markdown that has to do with Otter. And I've simplified the example to where you're going to see one question. We're going to run the command that would generate the notebooks. We're going to look at those notebooks. Then we'll go back and you guys can add your own question in and we can run the command again and watch what happens. So it'll be pretty straightforward, I think. There are kind of, 3 is one is create your notebook. 2, we got to execute this command, which we're going to do right in the hub. And then we'll write our own question and we'll move this along. Okay, so the goal here, right, when you use Otter-Grader, so just take a step back for a second. The goal is that you got to create a set of files that the students can render and use that have the little ellipsis, is that what we call it? The little ... that shows them where they're going to answer code. That Otter-Grader will make that happen for us. That's the student side. The other side is you're going to make the zip file, we call it the Otter-Grader.zip file, which contains all the solutions that the services that will automatically grade the notebooks of your students use to make sure they're correct. So that's why you have to run this Otter assign and get these 2 sets of notebooks that'll show up. And we'll see that happen. It's a really simple command that does a lot of complex stuff. That's really all you have to do. It's right there. and I'll show that to you. Okay, so the questions are actually the most difficult part. So there's kind of like the technology piece of it, which is actually not that bad once you get inside of it, but actually writing the good questions, that's like a whole nother workshop. So we're not going to worry about that part of like, what is a good question? What's a good auto-graded question? That's probably the way more interesting part to talk about. But this will show us how to get there. So there's kind of 4 pieces. You're going to get this assignment config in your raw notebook. You're going to import all your packages, write whatever content you're going to write, and then develop a set of questions. And each question has its own config, its solution, and the test you're going to run to see if it's correct. And so okay. What I've given you here is the bare minimum config. I'm going to go over to the notebook in a second. So there are full documentation in AutoGrader about all the, like, there's probably 30 different things you could put in the assignment config on a notebook. The bare minimum is just telling us, I'll explain to you as you guys see the notebook what these pieces do. And this is just the files I'm going to include with the notebook. So the data files that we might need. So let's see, let's go over. So let's wrong way. Right. Okay, so if you guys go into your hub and you open up this notebook right here, and that's super big, cool. So notice that it's just an IPYNB file, just like if you were there earlier today, it's just the same kind of file. The only difference is that when you do the assignment config, is that you've made, if you guys remember, I was talking to you about different types of cells. And those who are new, like each cell, there's 3 different types of cells you create in a notebook. One of them is called raw, which doesn't do anything. It's just like text. Markdown will do some of this. It'll like bold and highlight and color, and code will be used to run code. So anytime we do Otter specific things, we're going to use a raw cell. And nothing will happen. If we like hit run cell, nothing's going to happen. There's nothing to run there. It'll just let it go. The package is the same package that we've used a lot. And we would put any set of packages we want up there. And then we get down, and this is where it gets what we'll kind of see more of the config part of it. So I'm going to run these through, and then we're going to run Otter assign. So right now, all this will be done for you. So you might have some context for the question or the notebook, right? I put some information about the different types of cells there. We go down and we start looking at this question or how our questions start. So you have this config that's a begin question. You give it a name. You tell it that manual false means that you want it to be automatically graded. And I had a question earlier, like when you set up the points, it's a little, so I have 3 lines here. And what that means is that I have 3 tests. The first 2 are not worth any points. And the last one is worth 2 points. And I'll track that for us. So you got to connect this to the test when we get down here. You'll see the connection in a second. So you would have written a question, like some sort of context for the question. NBA, data sets, compute, display the difference, right? And it's some random question. And then you're going to say begin solution, end solution. And that's the actual solution that the students will not see. It's kind of tricky in that what you're going to get whenever you put an equal sign and you have this pound solution at the end of the line, that's what's going to generate the ... right here, like indicating or signing to the student, write some code here. So you have this begin solution, and then in the solution, you're going to put these tags where you want the students to actually fill in information. And then in solution, and then you start your tests. And you can see in the test, there's my first test, which was worth 0 points. There's my second test worth 0 points. And here's my last test, which was going to be hidden, which I'll talk about in a second, would have been worth 2 points. Go ahead.
So everything on the right-hand side of the equal sign becomes a ...
Yeah. There's other ways to do this. And like, so when you go into the Otter documentation, there's other ways to form questions. And I have prompts, and I have a notebook of examples as well. So the simplest one is put pound solution on one line, get a ... after the equal sign. Just save them, right? Because if you need this variable name somewhere else and they start writing variable names, the whole notebook's gonna get messed up. Yeah. Okay, let's use it. Yeah. questions, solution, a couple tests. In the Data 8 notebooks, if you look at the raw notebooks which are in the private repo, you'll see that these are extensive notebooks where they might have 10 questions on a page. One thing that happens a lot in the Data 8 notebooks is that these non-hidden tests, these are called public tests. These are when the student goes grader.check, if you've been in a notebook, on the student notebook, it's running the non-hidden tests. And a lot of those tests can be just like, is it in the ballpark of the right answer? And then we get down to the hidden test. This is only run when you go to Gradescope or you run it on our Otter-Grader service or when you want Otter grade. So that hidden test doesn't get run on the student side. So it is, and we see this, right, in like the homeworks in Data 8, you will see that the students get 100% when they run the notebook, but they've blown up something that only shows up on the hidden test. So they may not know, right? They may have not dealt with an edge case, or they did it a little bit funky and it didn't come out exactly right, but they couldn't tell from our public tests. It's just something to know. Okay, so how do we run this? So we have a notebook, we've got ourselves set up. If you go over to Auto Workflow, but this is an Eric idea that I think is super cool, is I basically wrote a notebook to generate, incredible, guys, this is my internet connection. Open, it'll work. Yes. Second. Yeah, down to the Otter Workflow. Cool. So I wrote a notebook to generate notebooks. So if you come over into this Otter Workflow, you could walk over here, mess around. This is our whole folder system thing that we talked about before, just making sure you're in the right folders using the PWD and LS-A.
But for half the people that weren't in the room, this is just like finding where you are and where your files are. So importantly here, you want to make sure that you're in the same directory as your files are.
What happens, just to give it a little bit more right, is what happens is that you could be navigating over in this side, but your notebook won't have moved, and you start changing where you are inside of the path without knowing it. So these commands help you track, where is my notebook? What are the paths I need? So okay, you see here that we have our notebook. It's in the same folder as this workflow one. We're going to be in good shape. So we come down to this Otter assign, and if we come in here and we write our notebook name, which turns out to be extensive.
HW-demo-NBA.
Maybe there's a place I can copy that.
Oh, nice.
Come on. Work. Okay, we go here, boom.
So the idea here is this is something you needed to learn to do at the command line. And we're like, oh, well, let's just put the thing you're supposed to do at the command line in the Jupyter notebook with an exclamation point at the beginning of the line, which gives you the ability to execute command line prompts, but the code is saved for you.
And what's going to happen is it's going to dump the output, those two folders, into this folder right here. You could call that whatever you want. So if we run that, here it is. Will the demo work?
Will it work? Live coding.
Kind of looks like it. It gives you some feedback. That warning, don't worry about that warning. It gets mad that one of the cells doesn't have an ID. But it looks,
there's a new folder.
And it restarted. So this folder that got created right here when we ran that command has the student folder and the Otter-Grader folder in it. This is where your distribution.
Sorry.
Go ahead,
So
Vita,
if we make a change to a file, to a notebook, and would like to add an extra problem or whatever it is, then we are going to
You're
have
here.
to.
Yeah.
Okay, and then
Finish your question. Sorry, go ahead.
So we come here and then we make the changes, and then we're going to also have to create the corresponding Otter notebook, which will create the blank student notebook.
That's right.
Why do you open the student notebook?
Yeah. So to follow up on that, this is why I keep saying, like, okay, if you're going to change a question, we're not talking about lecture notebooks. We're talking about self-graded, auto-graded notebooks. If you make a change to the question, you have to go run Otter assign again in order to then generate the student notebook with your change in it. If you look,
look at that.
You're like, great.
Player diff equals ...
That was our change there. the config that did the init cell, if you remember that's at init cell true, it puts that import in for Otter. And the export cell true, it does this export cell for you. So you don't have to include those, Otter will put those in. Export will just download the file for the student when they run it.
So there's two things. One is the instructor demo notebook.
Yeah.
And the other would be a lab assignment that.
That's right. That's right. And so when you're in the lecture notebooks are, arguably easier because you can just make the change you give to the students. But when you're in here and you want to add data sets, you want to add questions to assignments, you need to be in Otter to do that, yeah. So and if we look in the auto grader, so for all the data 8 notebooks, we've done all this and this is all published. This is what we did all this work and it's all sitting there for you. I don't know why I keep doing this. If you're in the auto grader folder, you'll see that you get the instructor notebook. We call it the instructor notebook, but that's going to have the solutions still inside of it.
So when the student comes to your office hours, you got to remember like how to do it. This is the one, or you can share with your TAs if they need the help, or the person who's doing the tutoring. So this is the copy you could share with somebody who needs the answers.
And then this right here, that zip file I created, that's what's used to run auto grade. So that was the conversation about grade scope. That's what gets uploaded to grade scope. The Otter service, the standalone service we have, you're going to give it that zip file in a series of submissions, whatever the students gave you, and it will grade them. That works incredibly well.
Can you show that there's a couple other files? Yeah, that you've made.
If we back up now to our,
there. What are those other files?
So thank you, Eric. Those files are, if you go to Otter examples and open it up, you're going to see a notebook full of different types of questions that we've collected. So some come from Data 8, some come from other professors on campus and ways they came up with that, making like a multiple choice question, right? Something like that, or they have manually graded questions. So how do people handle doing a kind of open-ended, what did this mean? Like, do you understand your, p-values or whatever? And maybe visualizations, right? Those aren't things we can auto-grade. I don't think we can auto-grade visualization. I think there's been discussion of that, yeah.
Piles has ideas.
Yeah, I don't think, at this point, we can't grade a visualization. So that would be like a manual.
So there's an art and a science to auto grading, right? There's like a tension here as a teacher where you're like, oh, I have to ask a closed form question that has a closed form solution, and I have to have the matrix. You can be like, what's the dimension of the matrix? Does it have exactly 4 columns and 117 rows? That's a possible answer, right? If I take row 3 and multiply it by something, do I get this number? Like, there's a lot of art and science to how to do auto grading. And there's a lot of combination of like, you can only learn so much from a closed form question, and there's other ways to assess other things. AutoGrader is not going to be the solution to all assessment. The other part that is really important, and is really important part of Data 8, is from computer science education, giving the students like real-time feedback that they're on the right track and the right things are happening is huge, right? You finished part A, you declared a function. Let's run something through it and see if we get the right output. AutoGrader can be like, yes, go ahead, go to part 2, you did it right. If they're like, oh, we need that function so that part 2 works, well, go back and fix it if it's not working right. Like, that's separate than assessment, right? That's giving the students, and Data 8 is very like that, where there's these auto-grading checks put through it that aren't part of assessment, that are part of telling the students they're on the right track and they're doing the right thing and giving them the little win. And giving them reassurance as they get through, like, what could be an hour to get through a lab.
So my idea from here would be for you, if you want to mess around and add another, sorry, I'm in the wrong place, to mess around and add another question. So back in on this notebook, create some cells, and create another question, and then run Otter assign again, just to give yourself a chance to mess around with it. I don't know how it feels to people. I don't know if that's where we are. Or that's where we are. Go ahead.
Just curious for students who get stuck. maybe they don't get any of the auto-graded parts right, even if they're laddered up. Who gets them unstuck? How does the grade process work if they just turn in something that's completely broken?
Well, I think when you're at Berkeley, there's a set of resources. When you're at the community colleges, you're it. But here they have a series of TAs and students that help them. They have online forums that help them, like what's it called? It's not Piazza, the unPiazza. Yeah, go ahead. Yeah.
I found it was really important to give students feedback per question, so to know, so they would know which question they got right. Because otherwise they just get a percentage right. So you can give them the feedback from Auto-Grader, but you have to give them a reference as well.
Yeah.
To say that you should have gotten 5 points on this question, but you only got 3, and then they can go back and study that question rather than being, oh, what do I do now?
Right. So Erin's at another level, another step. Like she's at another level too, but another step where, like, so there's in class or whatever, they're in there trying to work through, and they're not getting anything to pass. It's like, come to office hours, come find me. But then there's another level, which is you turned it in, you missed a bunch. And if you're in grade scope, it's a little bit simpler for the student to see what they missed. And the other solutions we're working on via Erin's inspiration, working on ways that each student could see what exactly they missed on each question without being given the solution. So they know they missed part A of question 3, what happened. So, but yeah, there's at least in the data 8 notebooks, I don't see a lot of people just flailing the whole way through, that there's enough supports going on. I mean, I'm sure it's happened, but I don't see that as like a at scale problem. Go ahead, yeah.
Graded questions. Is there a way to assign points to those so that you kind of have like a blank spot for those questions when you go to do grading?
Yeah, I was looking at that too, and I didn't see.
Or is there like an easy way to just export those manually graded solutions? Because it's kind of a pain sometimes to go back and like.
Yeah. So when you maybe I'm not understanding your question, but so you have a manually graded question, and when you say generate PDFs, where is it? Oh, we don't have one like that on here. So we need the export. So in the export cell, let me back up for a second. So when you do the export, it can make a PDF. Ooh, Eric, help me. Of the manually graded questions or the whole notebook?
You can do it both ways. You can make it of the whole notebook, or you can just have it make the manually graded questions in a PDF. Sometimes you can have it paginate so that each manually graded question is on a separate page. So you upload the grade scope to it.
Yeah, so we might look into that more, but this is the config.
There's a way that you tag the cells that you want.
Yeah, and this has to be set to true. So I think we did that on the data 8 notebooks, but there may be some other work to do there. But I don't think that you can include them. I think it's a separate, like you can't include them, the grade with the notebook. It's like a separate. Okay, yeah.
So you can like assign points.
Yeah, to those questions, and like the way I've seen people do it is they just take the manual grade question and say it's worth 3 points or something. But that's Auto-Grader doesn't take into account, right? This is driving me nuts with these things going back and forth.
As a follow-up to Erin's question, when we teach this kind of course in an asynchronous online format, it doesn't have access to an instructor or TA. Is there an option in Otter that if I use a lecture, a teacher notebook, let's instructor notebook, and the instructor adds some questions which are very similar to lab questions as a teaching aid, and then can Otter display just the solution after multiple attempts that a student needs to go through?
No. Good idea.
Yeah, like that. Then we get into like prairie learning, these kind of these kind of things, right? Yeah, that'd be super cool. Yeah.
What's interesting about Otter, right? Like, there's no server there. You're not connected to anything. It's just a Python package. It's just running little bits of code, right? So you're not like live connected to something, which gives it far less functionality, gives it far more transportability. Like anyone in the world can use it on 10 million different platforms.
I mean, this would be like converting Otter into a teaching tool. As
That
opposed
had
to just-
something that hooked into some API that had something to do
Yeah.
to it.
Yeah, as opposed to just, grading.
Yeah. Yeah. Adaptive, right? Well, what time is it? What do we have?
5 minutes.
5 minutes.
Well, live code this.
Live code, okay. Go ahead, Aaron.
Can I ask a general question? What
Yeah.
have people created notebooks for to supplement data 8?
Somebody in the room can, I know there are a couple people in the room that have been generating, yeah.
Something.
Yeah, go ahead, yeah.
We're just adapting data notebooks to have different like projects or data sets that we're working. So then you would want maybe different questions.
I know that Humboldt has been integrating new data sets and maybe you've swapped out some of the notebooks, yeah. And I think, I forget what school. I almost got it.
Sorry, JC, we haven't done it yet, but we're planning to create some notebooks to use in a flipped classroom setting.
Oh, yeah, flip card, that was right.
So the students work on some different things from the original lecture notebooks, but we don't need the auto-grading.
Yeah.
Context.
Yeah.
There was this great example. Joey Gonzalez is not here this year. He came last year, but in the pandemic, he was using Data 100. It's like the opposite of flipped classroom, where you open the notebook and the embedded video is in the notebook. So you watch him doing the video in the notebook, the thing that you need
You're
to do.
supposed to do that. That's cool.
So then it becomes really self-contained flipped classroom in the notebook.
So we've never shown the Otter process.
First time.
That's the first time we've shown it. It's for the brave to take on. There is a series of screen recordings that Eric referred to in the 0 to 8. I think we'll just leave it there. That go through the start to finish. It always looks so small on my computer. That explains more in depth with and without Otter-Grader. And so I think the idea here was kind of maybe kickstart people who want to do it, and it's just gonna like get inside and try it and call me or call us. I mean, it's hard. It's hard to get going, and once you get it, it's not really that difficult. But the ramp up to getting there, you're like, okay, why is it not running? Sometimes you'll run Otter aside, it won't work. There'll be random stuff that's not right. I had it all dialed in for you there. So anyway, there's this, and there's also kind of a simpler one. This is like start from scratch. And there's also just if you wanted to change one of the Data 8 notebooks or an existing notebook, kind of a quick and dirty change that you could get in there and ways to do that.
And a little bit of what we were trying to do today was, if we want to demo Otter, we used to be like, all right, well, you have to go download this thing and make sure that it's correctly installed on your laptop, which was really hard. But if you do it logged into the hub that you're authoring on, and Otter is installed on that hub, then that command line is going to automatically work for you there. So that's just like a mental model. Yeah. It works really well on the cloud server without you needing to configure your laptop.
Right. I mean, it can take hours that trying to get somebody set up on their own computer with it. If you remember that this Otter workflow notebook's sitting here and you use that workbook, I think it goes really quite smoothly. Cool, go ahead, yeah.
You're not going to take down the workshop data hub.
I was wondering about that as well. Yeah.
Behave as if it's not permanent.
Okay.
You can download your stuff.
You can right click on in here somewhere. In here and just download whatever you want.
Download folder as if.
Yeah.
But this all came from a public GitHub repo. Right?
That's true.
So Sean put these materials
I could
in a
get
public
those
GitHub
links
repo.
out there.
Those are there forever.
Okay.
Right?
That's the way to do it.
That's the way you want to think about it.
We'll get that. I'll get that link in the
resources.
Yeah. Cool. Well, thanks you guys. Thanks for hacking through that. We'll see. Good luck.
Say a few words about the California Community College supported data hub.
Yeah.
How do we get to that?
You talk to Sean Morris. you fill out a form. I'll talk a little bit about it too at the last session. That's 4 to 5.
Expensive.
Is that the instructor interest form?
Yeah, instructor interest form is a key place to start.
So we can set up meetings too throughout the next few days.